Hello, grade 11s. What we're doing today is we want to transform any quadratic equation that's given to us as f of x equals ax squared plus bx plus c. We're used to seeing that when we did completing the square, when we did quadratic equation. We know that's the general form of any quadratic equation, and we want to turn it into this turning point form. So let's make me less big over here and say that's our goal here. All we're trying to do is change this general form, ax squared plus bx plus c, and we're trying to turn it into turning point form. Once we've got this, we can sketch it quite nicely, and we can put the turning point in, and we've been dealing with this more than we've been dealing with this general form. Now, there are a few methods here. There's the simplifying, and there's all of this, and completing the square. And what I propose is, let's go simple. I'm going to ask you to remember one new thing. And we can look at the algebraic reasoning if you really want to. And yes, we always want to see why things work mathematically. I'm just going to ask you to remember one new formula. And it's this bit here. P equals minus b over 2a. P, remember P in the x minus p squared plus q here. P is the x value of our turning point. So that's our one new thing we need to remember. And that's it. With that little bit of information, it's pretty much the only new thing we need to know. Plus this, but you'll see that this is kind of makes sense. So P equals minus b over 2a. One of those in your sleep things. Like, what's the quadratic equation? What's the quadratic formula again? Wasn't it x equals minus b plus or minus the square root of b squared minus 4ac everything over 2a? Right? One of those ones that you just know. So here we go. Let's run through an example. F of x equals 2x squared minus 12x plus 2. And what we want to do is we want to turn this into turning point form. So it would be nice if we could write this as f of x equals a, whatever a is, we're going to work it out, x minus p, whatever p is, squared, plus q. In other words, determine the turning point of this quadratic of this parabola. Okay, so we're going to use our one new bit of golden information that we're just going to accept as fact. P equals minus b over 2a. So let's write it down. P equals minus b over 2a. That's our starting point. Let's write out that little equation every time just so it gets drilled into our head. What's our b value? Now notice that some of you were doing this when we did the quadratic equation. I think that's a nice thing to do. Let's just write down what our values of a, b, and c are. So I'm going to scribble them here. A, b, and c. From our example. A is whatever goes in front of the x squared. It's the coefficient of x squared. So it's positive 2. B, what's in front of the x? Well, here it's negative 12. So that's what the value of b is. What's our value of c? Well, it's just the constant at the end. It's a positive 22. Now we've got them there for reference. When we need to substitute them into any equation, they're just there, ready to go. Okay, so P equals minus b over 2a. Now instead of looking at which one is b, we've done that hard work. We just look over here and we go, b equals minus 12. Okay, so it's minus minus 12. Let's actually write that. So minus, this is this minus, minus 12. Time divided by 2a. What's our value of 8? No, it's just right up here. 2. Okay, 2. Cool. Plug into the calculator or work it out. Negative 12 is the same as a positive 12. 2 times 2 is 4. So P equals 12 over 4, 3. But of course, at the stage here when you had the negative 12, so where's it up there? Yeah, that stage over there. So when you were doing that, you could have just punched that into your calculator and got the answer, which would have been 3 in either case. Okay, so f of x we know now equals a. Looks like we don't know a yet, but maybe you can see it. X minus p. No, we just worked out what p is. X minus 3 squared plus q. So it looks like we still have to work out a and q. But a, I have the sneaky suspicion we know what a is already. Yeah, isn't it up here? Isn't it up there? A equals 2. So f of x equals a is 2, so 2 x minus 3 squared plus q. It's the same a. It's not like a funny now a different a. And let's just check it. X is going to be x squared, and it's going to become 2x squared. Well, that fits in with the original equation, 2x squared. Okay, so now we need to work out q. Now for this, we've got our f of x. And what I wrote here is then sub q equals f of p. Now it feels like there are lots of letters going in there. What is this bit saying? So this bit here, I'm going to write remember. This is a new formula to remember. And what this bit here means is we're going to substitute p, that's what that means, f of p, ooh, don't know what happened there, into our original equation. So substitute it into original equation. Okay, so press the wrong button here. Okay, so we got f of x equals 2x. So I said substitute it into the original equation. So in other words, to find out what q is, I said that we said q equals f of p. But that feels like could be too many letters. What does this mean? This, remember I was saying, was sub into original equation. So you don't need to write this kind of bit down, but that's what we're trying to do, sub into the equation. In other words, take our original equation and just put our p value in, and that will give us q. That makes sense because we know that PQ is on the graph. Okay, so let's just run through this and then let's maybe make sense of that. So f of 3. So our original equation was 2x squared minus 12x plus 22. F of x equals 2x squared plus 12, did I say plus? Minus 12x minus 12x, let's make sure I got it right here, plus 22. Okay, lots of scrolling around, and we know that p equals 3. So we're just going to substitute this into our equation. So f of 3 is 3 squared. Whenever we see an x, we're replacing with a 3, minus 12 times 3 plus 22 equals, definitely calculator for this one, 3 squared minus 12, 3 plus 22. Okay, gives us 4. Okay, so we've worked out that our q value is 4. So if we're going to write this in, and let's move this second example, we'll do just now. Excuse for a second, let's just get that away. So we worked out p and q, so now f of x equals, remember it was ax minus p squared plus q. A we said was 2, p we worked out was 3, and q we worked out was 4. And there we go. Now we could work out what the turning point is. 3, 4. We could read it off. What's A? 2. What's the value of B? Well, we wrote it up here, minus 12. So our process, and we're going to run through it in a second example. This was our golden thing that we've learned new. P equals minus B over 2A. And we could look at the reasoning why, but it's really just some algebraic reasoning of manipulation. Remember this. So we work out what p is, and we substitute it here into our equation. 2x minus 3 squared plus q. To work out q, all we do is we substitute this value we've just found out, the 3, and put it into the equation given. That's our process. Let's do one more example here and really let this sink in. So we're given now that g of x equals 2x squared minus x minus 3. And this is the same example from page 143, but we're going to use our quick way of doing this as opposed to they complete the square and do a few things which is more complicated than we need right now. So we said, what is that one new thing we needed to remember? P equals minus b over 2a. Okay, so let's work that out. Maybe it would be useful. A, B, C. A is 2, B is, there's a 1 there, so minus 1. C, minus 3. Okay. So P is minus B over 2A. So it's minus B value, negative 1, over 2 times A value is 2. Negative negative 1 is 1 quarter. Okay, that's fine. It's a fraction. Nothing wrong with a fraction. So g of x equals a. We know what a is. A is 2. X minus what's p? We've just worked it out. A quarter squared plus q. How do we work out q? All we do is we substitute this value we've just found back into the original equation. This is our x value, our y value will come out. This is our p, our q will come out. So g over quarter equals this equation, 2 quarter squared minus, substitute a quarter in, minus 3. Definitely calculate it up for this one. 2 quarter squared minus a quarter minus 3. I get minus 25 over 8. So we got minus 25 over 8. What we were working out here? Oh yeah, this was our q value we were working out. So let's put that in. G of x equals a, 2 x minus p. We worked that out to start with. Quarter squared plus what was q? Negative 25 over 8. So not plus, but minus 25 over 8. There's our equation in turning point form. If we had to sketch this, I know that that's going to be the x value, that's going to be the y value. I know it's going to be positive, so I know it's going to look like that. And I know that the turning point is at a quarter and negative 25 over 8. Not quite sure where the x and y axes are yet. Don't know where the intercepts are. That's what we'll do next. So that's all we needed to do, to change this equation into this form. Work out the p-value with our golden little new equation that we know, our formula. Substitute it back into the original equation, and that's it. So we're going to do some exercises with that and then use that information to sketch. But the heart of this first bit is just how do we change this form of the equation into this form of the equation? How do we turn it into from ax squared plus bx plus c into turning point form?